Hi, today we are looking at section 7.6, which is analyzing and transforming logarithmic functions. So first thing we'll look at is changing the base of a logarithm. So log base b of x can be changed into log base a of x over log base a of b. So we put whatever base we want for a, and whatever was here becomes in our numerator's logarithm, and whatever our base was here becomes in our denominator's logarithm. Now, typically for a, we will use 10 because our calculators tend to use log base 10 when doing calculations. So evaluate each logarithm and write the related exponential function. Okay, so what we will do is we will change this into essentially this form here, calculate it, and then utilize that to come up with an exponential function that matches this. So if we have log base 5 of 50, that would be the same as if we do the same base in base 10. So log of 50 divided by log of 5. Now that gives us 2.43. Now, if we want to change this into an exponential function, that would be 5 to the power of 2.43 equals 50. Next, we have log base 8 of 6. So this becomes log of 6 divided by log of 8. Now, if we calculate that, that gives us 0.862. If we change that to an exponential function, that'd be 8 to the power of 0.862 is equal to 6. Now to graph using a graphing calculator, we want to simply change from log base b of x to this form here. So log of a of x over log base a of b. So for example, if we wanted to graph y equals log base 8 of x, what we would really enter in our graphing calculators is log of x divided by log of 8. Now, if we were to then graph it with our graphing calculators, we should end up with something that looks like this. Okay, so next we will talk about transformations. So transformations of our graph y equals to log base a of x. So our function y equals c log base a of d times x minus h plus k, where a has to be greater than 0, c cannot equal 0, and d cannot equal 0, is stretched vertically by a factor of c, stretched horizontally by a factor of 1 over d, reflected in the x-axis if our c value is negative, reflected in the y-axis if our d value is negative, translated h units horizontally, and k units vertically. So for example, how is the graph of log base 2 of 2x minus 1 related to a graph of log base 2 of x? So essentially we have two transformations here. We have this 2 here, which would be our d value. And we have this here, which is our k value. So we can say it's being compressed horizontally, because that's what our d value does. It compresses or stretches it horizontally. Now it's by a factor of 1 over our d value. So it'd be by a factor of 1 over 2. And then this here is our vertical shift. So we have shifted down 1 unit.